The volume of a shipping box is modeled by the function v of x equals x cubed minus 10x squared plus 11x plus 70, and x is the length of the box. So we're going to list all the possible roots for this polynomial. So we're going to do p over q, or we can think of it as b over f, back over front. And so the back is 70 and the front is 1. So let's do this actually on the next page so there's room. So we're going to take a look at 70 over 1, so factors of 70. So those are 1, so that's 1 times 70, 2 times 35, 3 doesn't go into it, 4, 5 times, 5 times 14, 7 times 10, and those are the factors of 70. So to list all the possible roots for this polynomial, we're going to say it's plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 7 over 1, plus or minus 10 over 1, plus or minus 14 over 1, plus or minus 35 over 1, and plus or minus 70 over 1. Okay? So those are all the possible roots. We're just using the rational root theorem. Then we're going to show that x plus 2 is a factor of v of x, and then we're going to factor it completely. So x plus 2, so that means we're going to change it to a negative 2. We're going to use synthetic division. We're not missing any terms, so it's 1, negative 10, 11, and 70. So bring down the 1, so this is negative 2, negative 12. This is positive 24, 35, and this is negative 70. And that gets us a 0. So it's x to the 0, x1, x squared. So x plus 2 is a factor, and now we're left with x squared minus 12x plus 35 equals 0. Now let's factor the x squared minus 12x plus 35, and that factors to 7 times 5, so x minus 7 times x minus 5 equals 0. So those are the factors, and then of course we're going to need to know the intercept. So x equals negative 2, x equals 7, and x equals 5. So we're going to draw a rough sketch of the graph. We're going to label the x and y intercept, and the graph does not need to be drawn to scale. So basically we just need a sketch. So the degree of our polynomial is x cubed. We know that it is the leading coefficient is positive. Our degree is odd. So therefore, we know that the ends go in opposite directions in this way. So right goes up on the right and down on the left. Our intercepts are at negative 2, 5, and 7. X equals negative 2, 5, and 7. So let's put those on the graph. Negative 2, 1, 2, 3, 4, 5, and 7. Let's see, our y-intercept is 70. So we could just scale it, right? So let's just somewhere right here, this is 70. Okay? X-intercept is y-intercept is 70. This is negative 2. This is 5, and this is 7. All right, so we're supposed to draw a rough sketch of the graph, label the x and y intercepts. And so now we can sketch our graph here. So it does something like this. Now, the x values are the volume of the box. And so, number 1, our y value is the volume of the box. So when we're looking at volume needs to be positive. Okay, so I mean, of course, if we're making a box, we want to a positive volume, so volume needs to be positive. Also, each width of the box has to be positive as well. So if the volume has to be positive, we are looking at y values that are above the x-axis. For widths to be positive, that's our x values. So volume represents our x values. Our y values, Volume represents our y values. The widths represent the x values. They have to be positive. So we're looking at anything in quadrant 1. Okay, so we're looking at when x could be between, or x has to be greater than 0, or it's between 0 and 5, or x could be greater than 7. Okay, so x could be greater than 7. So those are all the possibilities. Now, of course, we have to plug it in to see which ones work. So let's say take a look at I'm going to look at the factored form here. X plus 2, and I can write that here. So we have x plus 2, x minus 5, x minus 7, okay, minus 7, and we want to know what values we could use. So we're just going to test a number that is, let's see, first between 0 and 5, a number between 0 and 5. So let's go ahead and pick 1. If I plugged in 1 into here, so 1 plus 2 will be a positive value, that'd be positive 3. 1 minus 5 would be a negative value, and then 1 minus 7 would also be a negative value. Now, it doesn't matter that, again, negative times a negative equals a positive. Yes, that is true, but you cannot say that the width can be negative, right? The width has to be positive. So I know that I would plug in when x equals 1, I'm going to get a negative width, okay? And so therefore, I cannot choose anything here. So let's choose a number that is greater than 7. So let's choose 8. So if I choose 8, 8 plus 2 is a positive value. 8 minus 5 is positive. 8 minus 7 is also positive. So the only way that this works is when x is greater than 7. So the values of x, which the volume for the shipping box makes sense, is, let me write that for you, is when x is greater than 7, these are the only values, that makes sense. Because the volume, and all widths are positive. Okay, so that's the full justification on that.